Greetings everyone. In this lesson we are going to look at trigonometry, introduction to trigonometry. Now before we proceed, I would like to ask you to subscribe to the channel, and this is the only way you can help us grow. Alright, so let's get started. What is trigonometry? Trigonometry is a branch of mathematics that is concerned with the relationships between angles and the sides. It's a branch of mathematics. You know, mathematics is like a tree and it has branches. You have calculus, you have trigonometry, you have sets, you have functions, you have variations and other branches. Okay? So, trigonometry is a branch of mathematics that deals with the relationship between angles and the sides. Angles and the sides. Okay? So now, there are basically, in fact, there are generally six functions when it comes to trigonometry. And these functions are, you have sine, which is abbreviated as sin. You have cosine, which is abbreviated as cos. You have tangent, which is abbreviated as the tan. Okay? And then the other three, you have secant, cosecant, and cotangent. Okay, these secant, cosecant, and cotangent, we'll look at them in the next level when you'll be looking at additional mathematics or A-level mathematics. Now, in this level of mathematics, we only deal with these three trig ratios or trigonometric functions, okay, which is sine, cosine, and tangent. Now, as the subtitle here reads, right and non-right angled triangles. Okay? So, in this tutorial, on this lesson, we're going to look at right angles, triangles, and as well as non-right angled triangles. Now, in this, today we will look at right angled what? Triangles. A right angled triangle is a three-sided polygon with a 90-degree angle in it. For example, we have this one. This is a 90 degrees angle. Then this one is also a right angled triangle. So now, how do you find the sides of a right angled triangle? Remember in grade 8 and 9, you learned about the Pythagoras theorem. The Pythagoras theorem is when you have a rectangle and the rectangle is cut in halves, starting from this point, like this. You have two right-angled triangles, or in other words, a rectangle is a combination of two right-angled triangles. Then you have this side, which is called hypotenuse. In grade 8 and 9, then the two were just called adjacent. But at this level, they may not be called adjacent. They may have different names, depending on the position of an angle theta here. Okay. So this one is theta, which represents an angle. Okay. Now these are sides. Now, how do you find trigonometric ratios? Trigonometric ratios, there is what we call TOA. TOA. We're going to use this one here. So we have then we have TOA. This for sine. This is the cosine, this is tangent. Therefore, the trigonometric ratios are sine theta, sine angle theta is equal to opposite opposite over hypotenuse. Hypotenuse. This one will be cos theta is equal to adjacent, oh, this one is just O, this one is H, this one is A, adjacent over hypotenuse, which is H. Then finally, we have tangent. So tan theta, which is tan angle, is equal to opposite over adjacent. Over adjacent. So these are what we call trigonometric ratios or trig ratios, these three. So you can just know this memory aid if you can't remember these formulae. So TOA, okay? So TOA. Now, how do you find when you're asked to find the trig ratios of this angle? Now, to find the trig ratios of this angle, which is angle A here, first thing is to know where the angle is. The angle is this side. Opposite of this angle is this side, okay? This is the opposite of the angle. Opposite, eh? Yes. So opposite is this, so we will write O. Then hypotenuse is where the right angle triangle is facing. The longest side is called the hypotenuse. Hypotenuse will always be hypotenuse. Are we together? Yes. Hypotenuse will always be what? Hypotenuse. All right? So this is hypotenuse, we just write H. Then the remaining side is adjacent. Yes, adjacent A. Okay? So here, which one will be the opposite? This side, right? So this one, because the angle is this side, this one will be the opposite. Which one is the hypotenuse? 12 or 13? 13 is the hypotenuse, right? So this is H. Then the remaining 12 is what? Adjacent. Very, very good. Very good. So now we're going to write trig ratios of these two triangles. Yes. Normally paper 1, that's why they bring questions from these right angle triangles. From paper 1. Paper 2 is non-right angle triangle. Very good. Any questions so far before we start writing these trig ratios from here? Clear? Now, do we know the hypotenuse? What is the value of hypotenuse? We have 3, 4. What is this? What is the value? We don't know, right? Yes. So, we can find the hypotenuse by using Pythagoras theorem, the one you learned in grade 8 and 9. Okay? Which is what? C squared is equal to A squared plus B what? Squared. C squared represents the hypotenuse, right? Okay, so C squared is equal to A squared. We can get any of the two, right? Let's get 4 squared plus 3 squared, yeah? Yes. Okay, what is 4 squared? 8. 4 squared is 8. 16. 16. What is 3 squared? 9. Okay, so C squared is equal to, what is 16 plus 9? 25. 25, huh? What do you do when you reach this stage? We square root, huh? Very good. We square root both sides. So C is equal to, what is the square root of 5? 25. 5, huh? We get the positive 5. So here is what? 5. It's very important to find this 5 because there is H here and here. So if you don't find the value of hypotenuse, you substitute nothing. Now, let's now write the trig ratios. Sin theta, we start with sin. Sin theta is equal to opposite over what? Hypotenuse, right? Yes. What is the opposite here of this angle, triangle? Adjacent. What is the opposite here? What is the value of the opposite? The value of the opposite. What is the value of opposite here? 4. It's 4. Okay, 4. What is the value of the hypotenuse? 5. So this is the answer. 4 over 5. You get it, huh? 4 over 5. Can you go to cos? We look at cos, huh? Yes. So cos theta is equal to adjacent, which is A over hypotenuse. Wongani, what is the adjacent here? The value of adjacent? Yes, here. 3. Okay? 3. What is the hypotenuse? 5. So it will be 3 over. This is how simple mathematics is, or when it comes to trigonometry. Okay? Then what will be the value of tan theta? What will be the value of tan? Tan is opposite over what? Adjacent, eh? Yes. Okay. What is the opposite here? 4. Very good. 4 over? 4 over, what is the value of A? 3. 4 over 3, eh? That's it. That's how we find what? That's how we find these trig ratios, all 3 trig ratios. But in the final exam is simple. 2 marks. Sometimes they can just remove this 5 here, right? And they give you 3 and 4. Then they'll ask you, what is the value of tan x? So the first thing, what's the value of sin x? Huh? X represents an angle. Sin x. So you know that the sine is opposite over hypotenuse, and you don't have the hypotenuse. So the first thing is to find the hypotenuse using the Pythagoras theorem. You get it, huh? Okay. So we've answered A. We've written all the 3 trigonometric ratios. These are the trigonometric ratios. Now let's write the trigonometric ratios of this angle, this one. Yes. Okay, this one. So I'll write this one, this angle from this side. Okay, this side, we'll write it from this side. Okay, so when you look at this angle first, what is the value of hypotenuse is 13, Yes. We don't know the opposite, right? So what you're going to do is to write the formula for the Pythagoras theorem. Formula c squared is equal to a squared plus b, a squared plus b squared. What is c? Hypotenuse. Where the right angle triangle is facing, is the, so it will be 13 what? Very, very good. Then you can choose whichever side you're going to put there. There is no problem. Let's put 12 as a. 12 squared plus b is opposite, so just leave it as b squared. What is 13 squared? What is 13 squared? 169, 169, 169 is equal to 144. 12 squared is 144 plus b what? B squared. Very good. So we'll solve for b squared, right? So we'll do 169 minus 144 is equal to b squared. This 144 will cross the equal sign. 169 minus 144, what's the answer? 169 minus 144? 25. Oh, 25 is equal to b squared. We square root, right? Yes. The square root of b squared is b. What is the square root of 25? we get the positive value. You know that the square root of any number, it can either be negative or positive. Now, this is the side. You only get positive numbers. We can't get negative numbers because we can't say from here up to there is negative 5 centimeters. We always use positive numbers when it comes to distances. So B is what? 5. So meaning here is what? Very good. Then we can find all the trig ratios. Okay? These are called trig ratios, or trigonometric ratios. Trigonometric what? Ratios. Okay? So, number 1 is sine, right? What is the formula for sine? Theta is what? Opposite over? Hypotenuse. You are intelligent. What is the value of the opposite? 5. Hypotenuse? 13. Yes, 13. If it can be reduced, reduce. Yes. Okay. Number 2, cos. Cos theta is equal to adjacent over hypotenuse. What is the value of adjacent there? 12 over 13. Okay, 12 over 13. All right. Thirdly, tan, which is the last one. Tan theta. What is the value? What is the formula for finding tan? Opposite over what? Opposite over adjacent. The opposite is 5 and adjacent is 12. Okay? Adjacent is 12. Now, we've looked at the introduction to trigonometry, and this is very important. Without this knowledge, it will be very challenging to solve advanced questions. So remember, we've looked at how to just write trig ratios, trigonometric ratios. These are trigonometric ratios. And we'll end here. The third question here is your work, your exercise. Try it, and I'll mark you. In the next video, we will look at how to find the theta, how to find this angle now. Thank you very much.